A torque of magnitude 12 kilonewtons applied at the end of a tank containing compressed air under a pressure of 8 megapascals. So there's a pressure of 8 megapascals. There's an applied torque of 12 kilonewtons times meters, which I'm just going to write in newtons, so 12,000 newton meters. And the tank has a 180 inner diameter, so d in is equal to 180 millimeters, so r in is equal to 90 millimeters. R out is 90 millimeters plus the thickness, which is 12 millimeters. So that gets us 102 millimeters. The thickness is 12 millimeters. Determine the maximum normal stress and the maximum shearing stress. Well, we're going to have a stress due to hoop, and we're going to have a longitudinal stress. We know longitudinal is less. Let's find hoops first. Sigma hoop is going to be PR in over the thickness. So that's 8 megapascals times the inner radius, which is 90 millimeters, over the thickness 12 millimeters. So let's do that real quick. 8 times 90 times 90 divided by 12. That's 60 megapascals. So sigma L is 1/2 of sigma hoop, which is 30 megapascals. So now let's find the torque, and that's really what this problem is about. So if we find a torque, we look at the formula. It is T rho over J. So T rho over J. Well, let's clarify some things. This is the outer radius because that's where the torque is the largest. And this is the polar moment of inertia for a hollow cylinder. So it's hollow. So let's see, what does that mean? Well, J is going to be pi over 2 times R out to the 4th minus R in to the 4th. Because we're subtracting the material that's not there. Because if you look at the cross section, it'll look like this. So that's going to be pi over 2 times R out, which is 102 millimeters to the 4th minus 90 to the 4th millimeters to the 4th. And so we get pi divided by 2 times 102 to the 4th minus 90 to the 4th. Oh. Let me try again. Pi over 2 times 102 to the 4th minus 90 to the 4th. And we get, oh, that's a lot. 1, 2, 3, 4, 5, 6. 66.968. 66.968 times 10 to the 6 millimeters to the 4th. So now tau is going to be 12000 Newton meters. times the radius, inner radius, which is outer radius, 102 millimeters. The bottom, we're going to have pi over 2 times, well, we did it, so 66.968 times 10 to the 6 millimeters to the 4th. And now we want newtons over millimeters squared, which is going to give us megapascals. So we need to convert the meters in Newton meters to millimeters. So 1,000 millimeters every 1 meter. So that takes care of this. And then we have, this becomes a 2, and these go away. And so eventually we'll get megapascals. So 12,000 times 102 times 1,000 divided by 66.968 times, oh, I have it right there, divided by my answer is going to be 18.28 megapascals. So now we can draw our little stress element. And what are we going to have? Well, if you think about it, the shear is coming this way. So if my stress element's like this, my shear is going to go here. And so it must go here, here, and here. And then we're going to have, this is sigma longitudinal, which is, we said 30. This is sigma hoop, which is 60. And then we have tau xy, which is 18.28 megapascals. So now we draw a Moore's circle, where this is my sigma and this is my tau. And we say, well, my x-coordinate is 60, 18.28. Y-coordinate is 60, minus 18.28. Actually 30. And so we'll say 10, 20, 30, 40, 50, and 60. So 60 and 10, 20. So 60 and positive 1828, so that's going to be roughly right here. That's my 60 and 1828. We'll do the same for the other one, but it's going to be at 30. So somewhere around here, this is my 30 and minus 1828. This is my y. This is my x. We connect the two together. We create a nice circle. Create a nice circle. We find the center. So the center is going to be 45, 0, 45, 0. And so the radius now is equal to what? Well, we can look at this distance and this distance. So this distance is 15 and this distance is 18.28. So we can say 15 squared plus 18.28 squared. What's it gonna be? Square root of 15 squared plus 18.28 squared, that's 23.65. And so tau max in plane is 23.65 megapascals. Now, sigma max is going to be 45 plus the radius, which is 23.65. So 68.65 megapascals, and that's the answer to my question A. Question B is going to be 1/2 sigma max, because we're going to have another circle here due to the fact that there's zero stress on the outside. And so what is that going to be? 34.32 megapascals. And that's the answer to question B. Well, I hope this was useful, and I will see you next time.